Welcome to the Azure First Day. I'm Roland. Together with Luke, I'll be hosting tonight's event. So welcome, Luke.
Hi, thanks. Good evening, everybody.
Good evening. For our first session, in just a moment, Yusuf will show us the way in monitoring and debugging distributed systems in Azure. I'm being a software developer myself. I'm really looking forward to that one. Really excited to hear about his experiences. And for the second session, we'll start at 8 p.m. sharp with Stefan and Jordi. We'll be introducing Windows Virtual Desktop to us and how to use Azure Devops for the image and software management. I have not used for Windows Virtual Desktop myself. Have you already tried it, Luke? Is this something you are experienced in?
Me neither. So
it's new for you as well.
Also new for me, yeah.
Well, then it's very good that they're going to show us the introduction version of it.
Yeah.
Because it all looks very promising. I only saw the stuff that's there online on it. So really looking forward to that one as well. But our first speaker is Yusuf, who's a software developer at Capgemini, and he's already waiting in the lobby, I think. Yusuf, are you there? Are you able to join us?
Yes.
You are. Welcome, Yusuf.
Hey, welcome.
Thanks, guys.
So very good to have you here. I'll not try to steal your entire introduction sheet, as I warned before. I usually do that, so I'm not going to do that this time and let you just introduce yourself during your presentation. But I saw on your LinkedIn page you worked on some very interesting projects as a software developer, including some Angular projects. What is your favorite technology stack? What is your go-to technology stack when you're developing software?
That's a good question. I used to be more a front-end guy, so I liked Angular, but lately I've been more into the way React works, because it gives more flexibility. And but my all-time favorite, I would say, is Vue, because the simplicity and the whole infrastructure in the community around it makes it like, I think, my favorite framework to work with.
Very cool. So you know almost every big framework out there for the front end.
Not in depth, but I built small applications with it, and at a certain point, there's a lot of style being repeated. So it makes it, when you understand the concepts, it makes it easy to switch.
Of course, yeah.
Especially within React and Vue, it's almost kind of the same. With Angular, for me, it was a steep learning curve, but at the end, I mastered that dragon.
Very cool. Well, then maybe we should have another session on your experiences and comparing those, because I'm really always struggling which one to choose. But that's probably not Azure related, so we'll have to do that another time probably.
Sounds good.
But well, Luke, do you have any questions for Yusuf, or are we just ready for the session?
No, just ready for a session. Yeah.
Very cool. Well, Yusuf, the floor is yours. Best of luck. And
good luck.
Any questions, post them in the chat for our viewers, and we'll relay them to Yusuf at the end of the session. We have some Q&A.
Thanks, guys. I think I'll start my presentation. So welcome, everyone, to my presentation about monitoring, debugging distributed systems within Azure. And before I start my presentation, let me first tell you something about myself. My name is Yusuf. I'm a software engineer at Capgemini for the last 3 years now. My hobbies are watching movies, specifically thrillers. I also like traveling. That's something that I haven't been able to do lately, but hopefully this summer that will change. If you have any questions or queries about the things I do or the project I worked on, you can find out more about on my website, yusuf.nl, or email me if you have something interesting. So let's get started with the presentation. Before we go in depth about monitoring debugging, let me first tell you about distributed systems. As you can see in the picture, on the right you will see a distributed system. As the name implies, it means a system that's been broken up into several components. And this is different compared to a more traditional monolith. That's a picture on the diagram on the left. And it's an architecture that has proven it has benefits. One of those are, for example, maintainability. when you have a new developer joining the team, it makes it easier for the developer to tackle one code base at a time instead of being overwhelmed with the whole code base at once. And also the repositories become smaller and easy to maintain. If a certain component notices a lot of traffic, you can scale up that component specifically, and also makes it possible for your application to scale horizontally. So that's a great improvement. Instead of with a singleton, you need to deploy several same instances of the whole application. Instead of only the components are under heavy load. And if a certain component has issues or turns off or whatever, then it will impact the whole system going down compared to that may occur within a singleton. But a distributed system doesn't only have benefits, it also has some downsides. I think one of the big ones are monitoring. Because a request can go through several components, it makes it hard to track the performance and the whole transaction to each component it goes through. And also, if something goes wrong during that request through the several components, it's hard to pinpoint where it went wrong or where it went down. So to tackle those issues on Azure, we have Azure Monitor, and Azure Monitor is an application within Azure, is a service of Azure, and it makes it possible as a service that helps you increase the performance and availability of your application services. It does so by collecting and analyzing and acting on the telemetry from your applications and cloud environments. So if you look at the picture on the left, you will see the different resources that may create the telemetry, and all those items will be stored within telemetry and buckets. So all the logs of telemetry will be stored there. And on the right, you'll see several components within Azure Monitor that will act on the telemetry items. As you can see, it's quite, Azure Monitor has a lot of features, and in this presentation, I'll only be looking at two features, specifically the application insights, and within that we'll be looking at the application map, the search, the Snapshot Debugger, and within alerts we'll be looking into the automatic alerts. So first, let's start with monitoring. Application map is a feature within application insights, and it visualizes the topology of your distributed system. And what that means is you'll see in one overview all the components that are part of your distributed system. And a component is an independently deployable part of your distributed microservices or application. So this can be, for example, an API or a function. And because you can easily see in one view the whole application, it makes it easy for you to spot performance bottlenecks and failure hotspots. Because for each component you can see metadata about how many requests came in, how many of those requests failed, how long each request took. And it tracks all it visualizes all the components because it will look at the HTTP traffic. But it may occur that certain dependencies are not being visualized. For example, a component that's not deployed within Azure, for example, an SAP dependency. And in that case, you can use the Application Insights SDK to add custom telemetry items within code. And this is something I will show you later on in the demo. So search is also a feature within Application Insights, and it's used for finding individual telemetry items. With the previous one, it uses data from all the telemetry items that went into the buckets, and here you can find individual items. And this is useful, for example, if you're searching for a specific log or an exception that occurred within your stack trace, within your application. And yeah, this can be quite expensive at a certain point because the amount of telemetry being saved. And to solve the issue, Microsoft applies sampling. And sampling is the recommended way to reduce telemetry traffic, data cost, and storage cost, while still preserving a statistically correct analysis of the application data. You can search for the items within the portal, but there's also an integration within Visual Studio that makes it possible for you to search the items within the editor. Alerts. Yeah. Alerts is a component that can be used for when you want to be proactively notified of irregular behavior. The previous two features were mostly looking into monitoring a situation that already occurred, something you want to be proactively notified. And the way it works is you first create an alert rule, and within an alert rule, you specify the resource you want to monitor. So this can be, for example, the application service. And then you create criteria that needs to be met. This can be, for example, an X amount of traffic that comes in over a certain period, for example, 5 minutes, and it will in the interval of each 1 minute. So it will look in that 5-minute period if it matches that at least, for example, 20 requests came in, and it is above the threshold. Then an action group will be notified. An action group will kick off, and this can be an email being sent around to a group. And when the email has been sent and the alert has been set, then it will be set to the status of new, and then you will need to monitor the condition. So you need to acknowledge the setting and change it later on to the correct condition and to show you that you've processed the alert. So that's the monitoring part. Now let's head over to the debugging part. Yeah, within Debugger, we can use Snapshot Debugger, and this is a feature within Application Insights. And this makes it possible for you to monitor exceptions that occur in live applications. And Snapshot Debugger collects the snapshots on your top showing exceptions, so that you have information you need to diagnose the issues in production. And as the name implies, it will create. You can see in the snapshot the state of the source code and variables the moment the exception was thrown. And this makes it easy for you to pinpoint what is going wrong instead of you need to go through all the logs the traditional way. There's also integration with Azure Studio that makes it possible for you to add custom snapshots in certain locations where you want to have extra snapshot when one is not enough. Remote debugging is kind of similar to the way you work with local debugging, but instead you will be attaching to a process of a live application. So that way you can add the debugging. You can debug your live application. To do that, first you will need to deploy your application using the debug configuration, and it is recommended that you don't do this to applications in production, because it can impact the users that are using the application in that environment. So it's recommended you remote debug an application that's set, for example, in a staging slot or in a staging environment instead of a production environment. So all the theories are very interesting, but I think people are more interested in the demo. So let's talk about that part. To show you how monitoring debugging works, I created small demo applications to highlight the distributed system. The application consists of an API, and with an API you will place orders on a service bus within a queue. And there's a function also listening to the queue, and it will pick up any new message and process that. It will perform some business logic and then write the results to a table storage. The API then can retrieve the results from table storage. So in our case, our components, our deployable components, are the API and the function, and we have two dependencies: the service bus and the table storage. But before we can start monitoring and debugging our application, we'll first need to create the application insight resource. That's the resource we'll be using to monitor and debug. And we need to deploy our applications, the API and the function, to Azure. And then in Azure, we need for those two deployed resources to enable the application insights. So first, let's head over to the portal, start creating the application insights resource. So in the portal, we will go to application insights, And then, as you can see, I already created an application inside this resource, but I can show you how I created one. Just for the sake of saving time. You would assign to a resource group if you already have one. Otherwise, you need to create a new one. As you can see, I already have one. And then give it a name. And then assign to a region. And in the resource mode, it is recommended you use the workspace based because that way you can have all the benefits of the log analytics workspace, and also because Classic has been deprecated. And that's it. I think after that, then you can review it and create it. But I won't be doing that step because I already have an application insights. And then if it's been created, then you can go to the resource. And as you can see, it will look like this. Now let's head over to the code. Now we're deploying our API and our function. So API is just a traditional ASP.NET Core application. And there's several ways to deploy application to Azure. For the sake of simplicity, I'll be using the Visual Studio to publish our application to the API, to the Azure, sorry. So you can just right-click on the project, select Publish, and then let me zoom in. Okay. It's a little bit readable, but then first you'll need to create a publish profile. I already have a published profile, so I can show you how a new one looks. So you would then select Azure. From there, you would select Azure App Service, and then the Windows variant, because we need some features that aren't available in the Linux version. And then here you would select, you would create a new app service if you already have one. I already deployed this, I already have one, but it will look like this. So you can create all the resources you need in Azure using Visual Studio as well. So same as before, you need to select a resource group and an app service plan to host it in. If you don't have one, you can create a new one, as you can see. After that, after you've been through all the steps, you will then have a new publish profile. And then the only step you'll need left is setting the service dependencies. And this is needed so that when you publish your API, it already has a connection to the table storage and the application side. So the dependencies we have from here. And the moment you set these service dependencies, you'll also set the connected services to these two resources. And this is useful because when this has been set, the application insights will mean that within Visual Studio, we will be using the application insights not locally, but the one you will have in Azure. And the great benefit of having that is then you can see here at the top what the application insights, telemetry data that's of this endpoint specifically. So as you can see, for example, details page has this amount of information about how it's performing in the cloud. And now we'll do the same for the function. And the function isn't that different compared to the API, the ASP.NET Core application. You'll perform the same steps to deploy it or publish it to Azure. So again, you'll right-click the application, select Publish. Maybe have it from here, and then you'll see the same window. And then I already have one, but just the steps are similar, where you go to the steps again. And from there, you'll go through it again. As you can see, I have here one error. And the cool thing about Azure is you can just, if you have error, you can just remove this, and then it will move all the profiles. And you can just configure it again. And when you configure it, you can see, because I'm already logged in with Visual Studio using my Azure account, it will automatically find our application insight resource I already have. So I can select it, press next. It will set everything correctly. Next, and then it will also install the dependencies that are needed and configure it correctly. And that's it. Close. And now, because it's now set correctly, it also will connect here correctly. Oh, it didn't. And here you can perform the same steps. Next, and finish. Close. So that's the now. And normally we deploy this, but already have published our application, the API and the function to Azure. So I'll be showing that part now. So if it's done correctly, if I would go to App Services, you would see the API and the function. And for the sake of time, I already done this before. So now the last step is enabling the application insights on these two resources. So you click for it. I'll start with the API first, and then if you go a little bit down within settings, you'll need to click on application insights. And normally this will be, when you deploy it for the first time, it will be disabled. Depending, you do the same way you deploy this as I did. And then it's just a matter of switch of a button. You will have the integration within your API and application insights. As you can see, it's connected to the application insight resource that I have created not today, but a while back. So that's the cool thing about Azure is that it makes it easier to connect all the resources that are already deployed within Azure. And further down more, you can even configure it more when needed. For example, we'll be using Snapshot Debugger later on, and also you can maybe select if you want to show the local variables what exception is thrown. So that's very cool, how easy it is to integrate an app service and application insights together. And within a function, it's similar. So select the function, and then from there, you will need to go to the application insights and just enable it. And as you can see, it's also connected to the same application insights resource as the one the API uses. So this saves a lot of time, but also makes the integration between all the resources much easier. So if I'll go back to the function, there's also two things I want to show. For example, if you look here, we have here a class called Telemetry Initializer, and this implements an interface from the Application Insights SDK, because with this interface, it makes it easier for you to override the default names of your deployed resource. Because this way, you give a custom name to the role name or role instance in this case, and this is very useful because the default name you'll get sometimes may be kind of confusing or not clear about which resource it is, and if you override it with a custom name, it just makes it easy for you to see what it is. And also, when we go to the function, earlier within application map, I was talking about also custom telemetry. So out of the box, application map will show you everything, but with this telemetry items, you can add also custom telemetry. So you just create a dependency for this case, or I call it a dependency, and a fictional component I also want to show later on in application map. So now that we have deployed all the resources that are necessary, let's start monitoring it. And before we can monitor, we will need to generate some traffic. So I'll start first by adding an order. As you can see, this base URI refers to our the address in Azure. So what this does is it will use the API to put a message on the service bus, and the function will pick up that order later. And now we'll retrieve the details. As you can see, it gave me a 500. So let's try another store. So let's try to get the details from store with ID number 1 instead of 11. Okay, so that worked. Okay, so now I also made an endpoint just to simulate a bunch of random orders. For example, the size of 10 is fine. So let's create 10 random orders with 10 random IDs. Cool. Now we've done that, let's head back to the portal and see how that, let's monitor the behavior I have created. So we will first go to the application insights, and now let's go to the application map. So, and I only want to see the last 30 minutes. Yeah, so sometimes it may be kind of difficult to see because I can't organize, but what you're seeing here actually is, as you can see, the custom names. So the big circles are our components, our deployable components. So in this case, you can see the custom name I passed to the function and the API, the orders API. And if we zoom in a little, maybe I'll refresh. Come on, show me a little bit more metadata. Yeah, it takes a while. While this loads, okay. I can show you, like, for example, also the dependencies has. So it looks similar to the architecture diagram I showed earlier. So we have here the API, and the API will use the service bus SDK, and it will put a message on the SDK. So that's the line what we're seeing here, and that will then we have a worker that also will pick up the message and then write the results to the table storage. And we also have here the custom telemetry I've shown earlier, the store.com within the function. And the cool thing about application map is it shows you very easily, like how the requests were performing. For example, you could see here the green highlights how many requests were successful, and here how many failed. And if you click on each component, you can see more information about a certain component. So if I go to compute, it will show you which resources this is about. So this is about the app service we created earlier. And if you go, for example, to our failing requests, investigate failures, then you can see here the 500 error we got earlier, and also which operation that was. So let's click on this, and let's click on details. As you can see here, so that was the request I performed. Store with number ID 11, and it failed, and it also got a no reference exception. You can also see which dependency it tried to access, and it tried to access the table storage within this table store order, and it returned 404. So that already indicates that that certain item wasn't present in the table storage. So that's the great thing about application map. It looks very similar to if it's done correctly, it looks very similar to the architecture you've created earlier. So now let's go to the search, and here we can find a certain telemetry item we want to find. So for example, let's say I want to find the tail block field request telemetry item. So first you'll select the time frame, and from here you can just keep narrowing down. So now it will show you all the items of the last 24 hours. But if I say only want the last 30 minutes, that it already like limits the amount of results I get back. And you can just keep on filtering till you find the certain log or telemetry item you're searching for. So, for example, I only want things that are with the cloud role name of the custom name I had earlier, for example, API. And from here, example, let's only find successful request. So this way we can exactly find the failed request of this certain resource. And as you can see, it will bring it back to the same place. So there are several ways to get information about requests that have failed, but also one that are, for example, are successful. So for example, the simulate order cut was done successful. And let's try another one. Yeah, so this is, for example, when I try to read the details of store number 1 that was successful. And you can even see all the telemetry items that belong to it. So it could find an item from store, and then it will pass. Now let's back to the application insights, and let's go to alerts. And alerts is a feature that you can use, like as I told earlier, to be proactively notified. I have a total of 3 alerts, and if you want to create an alert, first you'll need, as you can see, this has been one has already been fired, and let's create a new alert rule. So normally, like you would create, first you would select the resource. So I want to be notified everything within this code. So for example, everything that's being monitored within my application insights. You can add a condition, and this can be anything. You can make it as matching for your use case as much as possible. Instead of creating a new one, let's look into the one I've created earlier. So let me see my alert. So why did this alert fire? So as you can see, I put a threshold on that if there are more requests coming in that are above 30, then I will need to be notified. So the threshold is 30, and the actual amount was 63. So that's why the amount of requests that came in this, everything was connected to application insights, it got triggered. And if you go to here, yeah, so this is the actual rule. And the cool thing about this is, like, it will show you the threshold. For example, 30 I put in, and you can see also the actual behavior at this moment. So it makes it easier for you to see, like, is 30 maybe too low? Because now I have 2 peaks that were around 165 and 63, so maybe 30 is a bit on the low side. So now, for example, if I put in 200, you can see how 200 compares to the actual situation that's going on. And you can also put in the granularity, like that it needs to be aggregated every minute, and the frequency of 1 minute, every 1 minute that needs to check. Normally you would just put a bigger time frame, but for the sake of this, I put it quite quick after each other. And after that, you will need to create an application, an action group. I've chosen that the email that will be sent, and I can show you how the email looks like. So if it's done correctly, you will get a new email, and the email will look like this. As you can see, Azure Monitor alert was resolved because I clicked early on the alert. And of course, when alert has been notified, you'll need to go back. I need to address the actual alert, maybe a bit too back. Because after you, like for example, I've noticed the behavior, you can explain that. You can just say, okay, I've acknowledged the situation and add a comment to it to explain. And this will all be saved, so it makes it easier for us to have a traceable log of all the alerts that have occurred. So that's the alerts part. Now let's look into debugging. For that, we need to go back to Application Insights. And now let's go to failures. And let's maybe do the last 30 minutes. And while this loads, yeah, okay, it's done. So on the right, as you can see here, you have 81 operations, and for each, and this up, and also the amount of snapshots. And if you click on this, you can see the snapshot that Application Insights have made. So it takes a while to load the snapshot, but from here you can see the stack trace and how the code looks the moment the exception was thrown. And this is also, you can also download the snapshot and open it in Visual Studio, but it takes quite a while. So as you can see, the exception that has been thrown is a null reference, and you can also see the variables that were at that moment, and also the request that came into the function. As you can see, for example, table number 4. And this is something very useful if you don't want to go through the logs to see why something has failed. You can just go see the snapshot. And this is something you first need to enable on the Application Insight. So we enable this for the API, and within the function, you'll need to enable it using the host.json. So within the host.json, you'll need to add this configuration. Snapshot configuration is enabled true. That's the only thing you need to do for the function. For the API, you can enable this using the portal. And now let's look into the remote debugging. And remote debugging, yeah, it's quite similar to the local debugging, as I told earlier. So there's several ways. I always use these options. So if you select attach to process, and then from here you'll need to set the connection target, and this will be then the address of your deployed applications. So as you can see, this is where the application lives, and then you add the port 4024, and then the first time you may be asked to pass in the username and password, and that is something you can retrieve by getting the publish profile if you download that. So I also need to show you that first. Visual Studio isn't, come on, okay, that's fine. The Cloud Explorer isn't my favorite today, so yeah, the important thing to remember is like that you use for the first time you need to download the publish profile, and there you will find username and password you will need to pass in here. And when it's connected, then you'll see the processes that are available, and you'll need to select this one, the W3WP process, and then you can just attach. As you can see, it will connect into that process on the live application. And there's no certain way to see if it's done connecting, but let's try getting the details of the store that caused the error earlier. Cool, yeah. So it hit the breakpoint because it was. It takes a while to load, but let's see. Yeah, cool. So as you can see now, it hit the breakpoint on a live application, and we can see. Let me close this one. So we can now see the information about the variables. So for example, why did this fail earlier? As you can see, let me zoom in a little bit. So this is the result variable from our retrieve operation on the table storage. As you can see, the HTTP status code we got back is 404. So that would mean that result, but this variable probably is a null. So as you can see, the variable store is null, and I'll try to access a property on this variable that is null. So that explains why it failed earlier. So now let's continue. Now let's try again. So as you can see, it will say again the exception of no reference. So this is very useful for when you want to debug a certain issue that occurs only in production, but not necessarily in your local environment. There is a warning that is not recommended on live production. But it makes it easier instead of trying to mimic a certain situation on your local environment. Now let's head back to our presentation. So in summary, let's summarize this part. So out of the box, you'll get a lot of cool things within Azure Monitor. It's just a matter of turning on and off certain features that you want to use. It also monitor all the dependencies you have within Azure. For example, the service bus and the table storage will already be available in the application map, and the components you are missing, you can supplement that with using the Application Insight SDK. It works in a matter of you'll need to collect all the telemetry you have, and you can analyze the all telemetry you have and then act upon it using the alerts. And if you look at the features within Azure Monitor, I only have shown you the application insights and the alerts, where there's so much more I haven't shown you this presentation, but trust me, there's so much more cool stuff available. I think that's my presentation about Azure Monitor Debugging. Are there any questions?
Very cool. There are a few questions, certainly. It was an amazing presentation. I really loved your demos, tying so many resources together and making it so transparent in application insights where the problem was. I also really love working with application insights myself for tracing production issues, and it makes our life so much easier, I think. So it was a very good presentation. We had a couple of questions. The first one is when you have external services, because you now showed us are the internal Azure services.
Yes.
If you would have an external service that that won't expose any telemetry data, can you tell us a bit how that would look in the application map?
I think it's possible for you. I think it's not possible. It's possible for you to show you the components that are external, but to actually monitor, for example, the performance, then, for example, the amount of requests that failed. There's some within the SDK. It may be possible, but you will need to set up more code around that, for example, because it won't track as much as telemetry, for example, with native Azure resources.
Or Azure, that's logical, and that's I think what you meant, but because you said for Linux environments there are less features that are measured, and that's probably the telemetry data from the system itself, which is not possible to measure all of it, which you can do on a Windows environment, right?
Correct.
Yeah. So you would see for an external service, you would see the response times and the failures, and but you won't see the performance of it. Only the core response values, which you get in return. So that's.
For example, the Snapshot Debugger, it isn't available on all the types of APIs. Like, for example, I think it's not possible when you deploy your application within a container, because that behaves differently. So there are limitations about things I've shown in this presentation. that aren't applicable to all the types of API.
Of course. Well, there's so many powerful features in there, so I think there's something for everyone. You mentioned the Snapshot Debugger. I remember from the past, the good old days, that there was a maximum of snapshots you could store in Azure. Is that still the case? Are you limited to the number of snapshots you have?
I'm not sure what the service limits are, but I know that it's quite big, because you'll need to. I didn't do this demo in the Visual Studio because it takes a long time to get all the symbols. But yeah, you'll need to connect it to the table storage, and it gets quite big. And there's also a limit about how many snapshots you can make in a running application with Visual Studio.
During the day. And it has to be triggered, I think exception has to be triggered a couple of times, right? Before it actually makes a snapshot. So it.
Yeah, I made a conscious decision not including presentation, because I've noticed sometimes it didn't trigger to make the snapshot. So, and it takes quite long to get all the symbols to load within Visual Studio.
Yeah,
I like the feature, but for a demo, it just takes too long.
No, that's totally. But it's great to know that it's out there, because it's such a powerful feature. When you have that issue under a production environment, and you have to chase it, and you have to debug it. So it's very powerful that you showed it, I think. What I was wondering myself is there any GDPR risk in exposing those snapshots, because it will snapshot your variables and environments, and maybe there are some personal data in there?
That's a good question, actually. I've never thought about it, because you will have the state of the variables. So I can imagine that if there's sensitive information you don't want to store somewhere else, then you may need to make a conscious decision about if Snapshot Debug is a right fit for your environment, because because all the other features, for example, within application map, it only show you the metadata, so you won't see the actual information. But with Snapshot, as the name implies,
so it's okay. That's a fair point. Snapshot. Yeah, and I think that the retention is limited, right? It's only a couple of 2 weeks or something. It's retained, and then it's just recycled and it's gone. So
I always see it's a great alternative for, instead of going through all the logs traditionally.
Yeah. So that's probably the same question you have to answer. If it's in your logging data, then it can be in your snapshot data as well.
Yeah, same problem.
Yeah. Good point. I think I have one last question, Luke, or are there any last-minute questions I missed? I have a question on dashboarding.
No new questions incoming, so fire it.
Then I'm just going to do the dashboarding question. Because for application insights at the previous company I worked, we had the application data, the application map on a big screen, which was excellent because you could see your real-time status of your environment very visually. But for my current assignment, we're using Azure Devops. We're using Azure Devops dashboarding there. Do you know if there's any way to include the application insights data that is also powerful, that does not have to be the application map, but can we use it on our Azure Devops dashboarding?
Good question. I've never, I haven't tried it myself, but I know there's a lot of extensions and a lot of APIs you can get from application insights. So I'm not sure. I think we'll need to look into that, and otherwise you'll need to create your own custom extension that gets the data from there. And
that's almost even cooler because we're all software engineers, right? So
we all want to do that.
Cool widget.
Build it
ourselves. Build the features our employers ask for, but build this widget.
Exactly. Why would you use a extension that already exists if you can make your own again?
You're so right. We're just having to search a marketplace.
Because ours is better, right? So
it's always better, but we need application insights on that as well because it keeps right? Okay, well, I think we're through the questions.
Out of questions, Thanks.
Yeah, well, thank you so much, Yusuf. It was a very nice session. I learned a lot. And I think that is true for everyone. We'll now have a small break, so everyone can do a small bathroom break, get a fresh cup of coffee, or something else to drink, and then we'll resume the session at 8.
At 8.
With 8 p.m. sharp with Stefan and Jordi about Windows Virtual Desktop and also Azure Devops with image and system management, if I have it correct. But Luke knows it.
It's you're completely right. And otherwise,
it's Windows Virtual Desktop, and we'll see you at 8.
They will correct us when we're back. So
yeah, probably. Yeah. Thank you so much, Yusuf.
Yeah, thanks, guys.
Thanks, Yusuf.
Good luck to the other guys. Bye-bye.
Bye-bye.
Hey, and welcome back, everybody. Right on time, nice.
Very cool.
Yeah. Well, after the great session we had, we are jumped right to the next one. For our next session, we have two speakers. So welcome. Hopefully they are there. Stefan and Jordi.
Yes,
Yeah,
yes, we are here.
Hi, guys.
Welcome. I'm sorry, guys. I messed up your title totally.
That's okay. We will let you learn something about it. So
Yeah,
okay.
they'll for sure. Yeah,
Yeah,
it's up to you to right my wrongs. Thank you.
So we really need the introduction. Yeah, that's
Cool.
Yeah. Well, great to have you. I will not blow your title again and not steal your introduction. But I do have a question before we start, because I think virtual desktop, Windows Virtual Desktop, just arrived before COVID. Well, I don't think it has a part in in the spread of COVID, but do you think Windows Virtual Desktop helps in the whole working at home situation? Is there a big role for in it?
Yeah, of course, because what we saw, especially last year, when COVID-19 hit us all, suddenly a lot of companies needed some place for their end users to securely work remotely from home.
Yeah.
Without the need of expanding their on-premises environment and buying new hardware, but they just wanted a quick solution to be like fast, quickly set up a new environment for them to work from home or almost anywhere. So yeah, definitely it helped them a lot for those customers to set up Wvd in the cloud in Azure.
Yeah, makes sense to me. So yeah. Well, nice. Yeah, then guys, I would say take the stage and go ahead. Have fun.
Thank you.
Thanks.
Will do. So
it's yours.
Yeah, let's get started. Jordi.
Yes, let's start it. Let's do it.
So, okay. Well, good evening, everybody. Welcome to this presentation on Azure Thursday. Our presentation is mainly focusing on Wvd and Azure Devops, but with the focus on the image and software management. So we will start with a quick introduction from my side and from Jordi's side, and then I will do a quicker introduction of Wvd. Roland will also know what Wvd is. And I think after like 50 minutes or so, I will hand over the stage to Jordi, and Jordi will talk us through anything related to Azure DevOps, image management, software management, and how we at our company are deploying it. So let's get started. So my name is Stefan Dingewanse. I'm 32 years old. I live in the Netherlands in Dordrecht. I work as a consultant for Firma ICT. It's also a Dutch company. At Firma ICT, we are mainly focusing on Microsoft and the Citrix technology. And we are focusing on application and desktop delivery on Azure and endpoint management. Since the 1st of January this year, I'm also a Microsoft MVP, and this is all has everything to do with my contributions for the Wvd community. Well, as you can see, I'm also the co-founder of the Wvd community together with two awesome people. We set it up last year, and I'm also one of the co-founders of the Dutch Wvd community user group. So, well, basically, I do everything with Wvd. The modern workplace, Azure, so that's my focus for the last few years.
Well, I'm Jordi van Drunen. I'm 33 years old. I live in Oudenbosch, also in the Netherlands. I work also at Firma ICT. I'm a senior platform engineer and consultant. I'm working there for about 13 right now, I think, and yeah, I'm pretty much an all-round engineer. Last years, I'm focusing more on Azure and DevOps and scripting and automating everything around that. Especially for Wvd, we made large steps, but also infrastructure-based code by code for Azure in general, and PowerShell scripting. So that's basically me.
Cool. So what are we going to talk about tonight? I'm not going to walk through every single step we are going to talk about, but mainly we'll have a quick introduction of Wvd, the architecture, the connection flow, and some things about image management and shared image gallery. It'll be like a quick 101 introduction to Wvd. And right after that, Jordi will talk us through the Azure Devops, the infrastructure of Wvd, infrastructure as code, shared image gallery, YAML, pipelines, everything related to deploying and maintaining those images in those environments. So let's get started. So what is Windows Virtual Desktop? Windows Virtual Desktop is a desktop and application virtualization service that runs on the cloud, on Azure. And it allows us to create a full desktop virtualization environment in our own subscription. So what does Wvd do? Well, it gives the end users, the customers, the employees, the ability to access their Office desktop or applications basically on any device from any location. It supports Microsoft 365 apps for enterprises, or Microsoft 365 Pro Plus as it's called before. And it even supports Windows 7 with some extended support with the security updates. So, well, like I said, I'm just going to do a quick introduction of Wvd. I don't know if you know this diagram. I think it's the easiest one to explain Wvd, and Wvd as a service, and most of the time it's called a DAS service, desktop as a service. In the middle, we will see like the Microsoft managed part. So Wvd consists of like 3 buckets. On the left, we will see the client. On the middle, it's all Microsoft managed, and on the right, it's our responsibility. So I will quickly walk us through the architecture. So the components in the middle. So for example, the web access, the gateway, the broker, diagnostics, but also a database are the components which are managed by Microsoft. So these things are also called like the Wvd control plane, and it's being managed and updated by Microsoft as well. So basically, we don't have to do anything about it. It's all being done by Microsoft. So we don't need to worry about that part. That's the managed part from Microsoft. That's the service part from Microsoft. Then on the left side, you will see all the clients. So like I said before, basically you can connect with every client to Wvd. There is a HTML5, a web-based client. There is a client for iOS. For Linux, there is a Mac OS client. There's a special Windows remote desktop client for Windows 7, Windows 10. And even there's also a Microsoft Store client for connecting to those environments. Most of the times you will see that users are connecting via the remote desktop client. The reason why is because that's the only client which is also supporting, for example, the audio and video offloading for Microsoft Teams. So, well, it's almost highly recommended to use that one. But again, you can almost use every OS to connect to it. And then on the right side, because, well, there are a lot of components managed by Microsoft, but there are also components we as an IT administrator needs to manage by ourselves. And it all starts with those virtual machines, those session hosts, those machines where if a user logs on to Wvd, it will get a session on a virtual machine. Like I said before, we can have a complete desktop, so a full desktop environment, or a published application. Either way, it's a virtual machine with some compute, and we can choose almost every VM size which are available in the region you are deploying to it. On top of that, we also need the Azure Active Directory. The reason why is because we need to authenticate to the Azure AD. If I go to the HTML5 client, I need to authenticate to Azure Active Directory. But we also need an Active Directory, like the legacy one. We still need those session hosts to be joined to a domain. Microsoft is supporting the Active Directory, but also the Azure Active Directory domain services. It's a service from Microsoft where they will deploy your domain controllers, high availability. It's all being managed by Microsoft. Later on in the same presentation, I will also give a little hint about the future about this legacy Active Directory, because I know they're also working on integrating it with the Azure Active Directory. But more on that later. If a user connects to via remote desktop to a session host, they will probably have some configuration settings for that session. So, for example, they change the layout of the screen, they have some desktop icons, their start menu. We want all those configurations to be saved. That's where FSLogix come in. FSLogix has been acquired by Microsoft, I think back in 2018. And instead of using roaming profiles, I don't know, but I think everybody has heard about roaming profiles. It was a pain in the ass. You had to copy your profile. It took a long time. The bigger your profile gets, the longer it took. With FSLogix is a containerized profile solution where basically when the user logs on to that device, a VHD or a VHDX file is being attached directly to that session host, and almost on the fly, their complete user profile is available. So for that, we need a shared storage location. It can be Azure files, it can be Azure NetApp files, it can even be like a traditional VM deployed with a file share on it. But again, then you have to also manage it by yourself, update it, and all that stuff. But that are basically all the components within the architecture of Wvd. So now for connecting, because we now know that we have some clients, there is a part which is being managed by Microsoft, and there is a part where we, as an IT professional or our company, are responsible for managing it. So I will quickly walk you through the connection flow. I also got a small video about it. So let's get started. When you deploy a session host, so a machine where the user will log onto, you also install a so-called Wvd agent. That agent will connect to the broker servers. It's an outbound connection to that broker servers. As soon as a user uses the remote desktop client or the HTML5 client, it will authenticate against Azure AD, and it will give access with a token to the web access portal. In the web access portal, they will see the resources which are available for them to use. So, for example, a published application or a desktop. When the user selects the resource, the remote desktop client or the HTML5 client connects directly to the gateway. At that moment, the broker part of the environment will orchestrate the connection from the end user, from the client, via the gateway, via the broker to that same machine. So at the end, what the user sees is a session on that virtual machine, and the connection is going through a gateway and the broker knows, okay, so this machine is free, it's available, there are not enough users on it, I can put that user on that session host. That's just a quick overview of the connection flow. I also got a video on it, and I hope it will be playing, because I
Yes, it is.
Yeah, it's working. So I wanted to do a live demo, but just before this session, I tried it, got an error, and I thought, well, hey, this is it. So what we just saw is logging into the HTML5 client, authenticate against the Azure Active Directory. Now you will see your resources, and it will launch a session to a virtual machine. You will see another prompt. I will talk about more on that later, but that's the authentication to your own Active Directory. So basically, in a few seconds, this end user has made a connection to their own machine via the shared services from Microsoft, via the HTML5 client, and that's it. We just talked about the architecture, and there are a few components within Wvd which are quite handy to know what it is and what it does. So I made a little overview of the most, well, I think the most important ones. I call it the Wvd terminology. So we got the Wvd service. With the Wvd service, and with Wvd it's the only service, we also got the Windows 10 multi-session. What is Windows 10 multi-session? It's a Windows 10 operating system which can handle multiple sessions at the same time. In the past, or still with remote desktop, that was only available with a server OS, also called as terminal server, where you could log into one machine with multiple users at the same time. So with Windows Virtual Desktop, it also ships with Windows 10 multi-session, and again, it's the only way to get a fully supported and a fully working multi-session environment running with Windows 10. Like I said before, FS Logic Profile Management Solution is almost the only way, and it's the way to go to store your profiles as containers when working with FS Logic.
In a modern way, yeah.
In a modern way, yeah. Then we got MSIX App Attach. MSIX App Attach is quite new. I do know that it's already GA. What is MSIX App Attach? MSIX App Attach is a combination of two technologies. It's MSIX. It's the new package format from Microsoft. So in the past and still we got MSI. There's a new player in town. It's MSIX, and with MSIX App Attach, what you are doing is basically extracting a installer, so an MSIX package, into a VHD file, and that VHD file will mount to that session host. So what does MSIX App Attach do? It will instantly connect an application to a session host, make it available for an end user without even installing it on that machine.
Or streaming it like FV, for example. So it's the successor, or not a successor, it's an alternative.
It's the next step. So it's not quite mature yet. The success rate of MSIX packages is quite low, but they will get there eventually. They will get there.
The technology is good. Yeah.
Yeah. Well, then we got a few Wvd components. We got our session host. A session host is nothing more than a virtual machine on Azure. It can be a Windows 7 virtual machine, Windows 10, a Server 2012, 2016, 2019. It's all supported with Wvd. A host pool. What is a host pool? A host pool is a collection of those session hosts which share which has one big thing in common, or two things. Those are all the same size, the same VM type, but also have the same applications on it, so working from the same image. So what is a host pool? It's a collection of all the same session hosts together. On top of that, we got the remote applications. A remote application could be a remote desktop application, so the icon to launch a fully configured desktop, but also a remote application as in just Word or just Excel or Outlook or any application you want to publish. Then we got a remote application group, and that's just a group of multiple remote applications. A user will get access to a remote application group, and when the user have access to it, it will show up in the web portal, in the remote desktop client, on their phone, on their laptop, on their endpoint, anywhere. And then for the last two things, we got a workspace. A workspace is like a logical group of those application groups. It is almost a thing which combines all the host pools, the application groups together in one workspace. And then there is the metadata location. And this is not something new, but suddenly there's a lot more information about what is the metadata. So the metadata location is, like it said, the location where the metadata for Wvd is being stored. In the past, it was only available, I think, in the US, East US, West US. Those were the only regions in Azure where you can store your metadata location. Nowadays, it's also available in Europe, so in West Europe, in the Amsterdam data center, and the metadata is a combination of information from your Wvd deployment. So the host pool naming, the naming of your applications, the user principal names which has access to connect to a Windows Virtual Desktop environment. Those are all being stored in that location. Well, that's basically it. Those are I think, the most important components of Wvd. Some features of Wvd. Some features, there are a lot more features, but I just want to highlight a few of them because I think those are the most interesting things on features with Wvd, and those features are not all in like general available, are mostly in preview, or even some on the roadmap. So let's start with Start VM on Connect. Start VM on Connect is, I think, one of the coolest features of Wvd. What it does is, for example, you got 10 session hosts. Middle in the night, all the session hosts are turned off. So they are not consuming any CPU, any memory. You're just paying for the storage. In the morning, the first user logs on to their machine, but that machine is not turned on. It's not allocated. Start VM on Connect will make sure that when a user tries to connect to his personal machine or to his pooled machine, that machine will be turned on and powered on automatically. So it's an instant cost saving when you use things like Start VM on Connect. Then we got audio video offloading from Microsoft Teams. It's only supported with the remote desktop client, and what it basically does is offload the encoding and decoding of the Microsoft Team, like audio and video traffic, to that local client. So the remote desktop, the session host, doesn't consume all the CPU and memory of that encoding and decoding, and it will be handled by your local client. Then I will just skip a few also for the hands of time. So single sign-on. That's, I think, one of the biggest features every company is being asked for. Single sign-on, in this case with Active Directory Federation Service. It's announced, I think, 2 weeks ago, and maybe you saw it in my little video. The first time I connect to Wvd, I will authenticate against Azure AD, and the second time, because of that connection flow, I have to authenticate against my normal Active Directory, the domain where my session hosts are being part of. With single sign-on with ADFS, there's no more second authentication prompt. It will help my and the end users to just put in my username and password once, and I will eventually log on to my session host. There's a thing called screen capture protection. You can turn it on for a host pool. If you have a session and you want to share your screen via, for example, Teams, or if you want to make a screenshot, you won't be able to see any information within that session. It's just a black screen. Nothing more, nothing less. You cannot share that information. So it's also very secure for things like hospitals or environments where they need a more control over what can be shared or what can be seen on your physical endpoints. Then there's also Microsoft Endpoint support. So basically, you can just support or manage your Wvd session hosts the same way as you would with your physical devices. You can enroll them in Intune. You can hybrid join them to Azure AD and to your normal AD. You can have compliance policies, configuration profiles. You can do anything you do with Microsoft Endpoint Management. And it's supported for the single session and multi-session. And then it's not there yet, but it's on the roadmap, the native Azure AD join. Nowadays, when I want to deploy Wvd, I have to make sure that that machine is being joined to a domain. If I got a company which is going full-blown to the cloud, I still need that legacy domain controller on-prem or on Azure, but I still need it to make my session host join the domain. With native Azure AD join, Microsoft will fully support that machine, that session host, will be just joined to the Azure AD, will be enrolled into Intune, and can be managed directly with Endpoint Manager. You don't need that ADFS anymore because there is no single sign-on, because the only way you authenticate is with your Azure AD credentials. Pretty cool, right?
It is. It is.
So what about the time? I'm not sure.
You're pretty far in.
Yeah.
Do that. So we have 20 minutes left.
In total.
In total. So go on.
Well,
skip to the demo.
Then I will just skip a few things because we didn't have that much time to rehearse this whole presentation. So I will just skip to this part. Like I said, in the buckets there is a few things we as an IT professional need to make sure to do. Those session hosts need an image. That image needs to be managed. What do I mean with image management? It's building and also maintaining your golden images, your master images. A master image contains applications, updates, configurations, and I know, you know, we need to update that every month. There will be every month new security update patches from Microsoft. There will be new updates from Adobe Reader. All those applications need updates. So why is it important? There are, well, two ways. There is the traditional way, which is being used mostly in the on-prem environment, System Center Configuration Manager, Microsoft Deployment Toolkit, or as we call it, Poor Management SCCM. When the management doesn't have enough money, we will just do it manually or with scripts, and we can build and reuse the same image, install applications, install updates, and deploy it. This complete session, this presentation is mostly about the modern way. It is about the modern way. And there are two options, I think. It's the Azure Image Builder. It's a service from Microsoft, as you can see on the picture. Very quickly, there is a source image based on Linux, Windows Server. You will do some customizations in it, and you will spit it out and distribute it across regions, and you can use it to create multiple virtual machines. And then the fun part, and that's the part where Jordi will talk about, and that's the Azure Devops part.
Yeah.
And I will skip the rest.
Shared image
because
gallery.
We are
all
way over time. There are three types of deployment. You can do it via the Azure portal. There are RM templates, and now the fun stuff with Jordi. And Jordi will tell us everything he knows and has built for Firma ICT to deploy and maintain those images and to deploy fully automated a Wvd environment. And we can now switch to Jordi. Sorry for the time.
Nope, no problem, Stefan. We'll fix it. So let's dive right in. To have image management, you need to have software management because you cannot create an image without software, right? And everything you hear and read about in the internet is how to create an image and maintain it, but they don't say anything about what you need to do with the software. So at Firma ICT, we've built the software management pipeline, we call it. Basically, it's a multi-phase stage and pipeline, which does a lot of things, which I will take you through in this small journey. The first stage we're going to look at is the the top one. It's basically gathering or uploading manifest files, configuration files, or PowerShell scripts, and yeah, we upload it in a Git repo. From there, we're going to test if the scripts are valid, if the manifest is according to a standard we have. If that's okay, then we sign it and we publish it in an Azure Artifacts store. Azure Artifacts is something within DevOps which you can store your artifacts in. Pretty much, an artifact is something you can generate with Azure DevOps. It's kind of like a zip file, but immutable. You cannot change it when it's in there. It has a fixed version. You cannot replace the same version, so you need to have a new version in there. That's why it's ideal for versioning. So stage 2, the most important step in our process. Basically, the pipeline downloads the external resources that are available publicly. So think of the installer of Google Chrome, Mozilla Firefox, Adobe Reader, 7-Zip, all that kind of software that's publicly available will be automatically downloaded by the manifest configuration. So we have a configuration file that defines which applications we have and where we can download or check for a new version. As soon as the sources are being downloaded by the DevOps agent, we combine it with the installation scripts or generate scripts if we only have a manifest file. And when we have a package with all those things, we're going to test it. So basically, we just deploy it, see if it's installed. When it's successfully installed, we sign the package we have at the DevOps agent, and we upload it again in a new Azure Artifacts store. This way, I have a verified package, and this package can be deployed to multiple resources. And that's the release phase in this entire image. Basically, we can generate exe files, we can generate IntuWin files, we can generate packages. And I call it the single input, multi-output pipeline. And besides of the packages I just called earlier, we can also make a connection with an MDT server or SCCM. We can generate winget manifest files. We can host it on a private winget repository, which we can deploy to customers. We can generate MSEX app attach packages. So I only create one manifest file or one package from VMNST itself. I do it once, and it will get generated for all those endpoints. And I've just added a few dots down there because in the future, maybe we have something else to publish to. So I'm going to show you a package from it. And the basic thing you need to understand is that this is the basic for image management. And when we go to my sandbox, I have two packages here, and it's 7-Zip and it's Adobe Reader. And obviously, it's not reacting as I want to. First, I show you that 7-Zip is not installed right now. So I'm going to install it with a package that's been generated by us. And the package has been signed and cannot be changed without losing the signature. As you can see, the signature is valid. If it's one, yeah, it's okay. It says here, and it's valid. We can just safely install it because we know we've created it ourselves. And everything that's in the package, I will show you as soon as 7-Zip is being installed. We have, at the moment, I think, 250 packages in our store. This is the exit files are the ones we give on with the engineers that are en route. So if they are there with a customer and they need to install some software, they have the credentials through our vault. They can just install the executable, give the password in there, or use the local admin accounts, depending on the customer, and they can just install it. They know this package works because we have tested it. Now, my machine is currently under heavy load, I think. Normally it installs within 30 seconds or so. You know, 7-Zip is not that hard. And at the moment, it's taking a lot of time.
Live demos, right?
Yeah, always. I need to create. So my laptop is getting hammered right now. Everything is slowing down. Okay. What is in the package? A package from VMNST contains at least 3 files. It contains a catalog file, which says something, or it tells the hash about the zip file that's also in there. The zip file contains the sources, and it could just be an executable, it could be an MSI, or it could be separate files, it could be a registry file, it could be anything. But the catalog file is showing the hash and verifying the hash of the zip file. So if you change something in the zip file, the catalog file won't work, and that way the script that checks the catalog file also fails. The PowerShell script itself is also signed. And wow, this is taking a lot of time. I'll switch back to that later on. Let's go to the next one. I'll leave it open, and as soon as it's been installed, I'll switch back. So what does the script look like? We have a template we have created, and the template contains a lot of functionality. All basic functions like extracting the zip file, getting the zip validation information, getting the registry ready to log which version we're installing, if it's installed, by who it's installed, all that kind of stuff. We have some basic logic. We can install and remove it with the same package. It's all in here. This is the stuff our engineers don't touch. So we'll put it back together. We have some part here that our engineers are also editing themselves. So they just change the scripts or the manifest, and they upload it in Git. We usually use branching, that kind of stuff, but I won't go into that one. This is one of the lines they are adding to the script. Basically, it does a start process, MSI exec, and it's shows the MSI in this case. So it's the one for 7-zip, only this is an older one. And it tells the MSI exec that it's silent installation. So our engineer have uploaded it, it goes to our pipeline, and we get all the packages in there. And I think when I'm going back right now to my sandbox, it's installing. So it took some time. And as soon as 7-zip is installed, I can show you the result of a package. And as you can see, 7-zip is installed. I can just open it. And like I said, I have a catalog file, I have a PowerShell script, I have a zip file. I even have an image specific for Intune later on. And I have a simple install CMD file. And because the zip file the exec file is just a self-extracting container, we just use this command to make sure we start the PowerShell script. And by enforcing a remote signed, I am sure that the PowerShell script is okay because we signed it. So all mechanisms in place make sure that we have a secure file. So back to the template. We also have the remove function in here. So as soon as our engineers have filled in everything that's needed, so they need to have the basic information about the script, release notes, where to download it, which file we're using to set up, all that kind of stuff is needed to make the pipeline working. And by saying that, we're going to the DevOps pipelines, because we already have our software now. I've showed in the time I have, I've shown you a basic understanding of how Veerman ICT is. Rules asking me if I can zoom out a little. Is it that bad to read, or?
Yeah, zoom in, but it's the Visual Studio part.
Okay, well, I'll zoom in the next one. Okay, I'll show you later on. Back to the presentation. The DevOps pipeline designer, or nowadays it's called the classic release pipeline, is the way we started. So we just used a build in Azure Devops to gather all the information, the RM templates, that kind of stuff, and we had some release stages. As you can see here, we just created a new image, we deployed the Wvd management portal, we deploy a shared image gallery, we deploy a VM applications, and we create an image, and everything was separated. And it worked fine, it worked great. The thing was that when we had a new customer and we need to create a new pipeline, we had to do it again. There's not something like export import that works great in the classic release pipeline. So there comes the YAML pipeline. Let me start with the major differences. The YAML pipeline means that you have a YAML file which contains the definition of your pipeline. And in the images shown here, the left one, it means you have Azure Pipelines as part for your YAML, and basically everything in one. So you have your build and release in the same file if you want. You can also have a release, but I would not recommend that. And the right image is the classic one. So you have a continuous integration task, and that it's called the build. It always creates an artifact you need in your release, and from there you do a graphical interface that controls your release. I have highlighted some of the major differences between these two. I'll start with the environment. You can deploy anything against an environment, and through an environment you can attach a VM, an app group, or that kind of stuff, and you can just deploy against it. And what's in the environment doesn't matter because it's separate from your pipeline. It's only available in the YAML pipelines, and I use it mainly for approving because that's also one of the features of the environment. But it has a lot of potential, and it's they're adding new features every couple of months, I think. We have service containers in the YAML. So I don't think I have to explain to you how that works, but it's better than your own agents, and you can just containerize your build agents, and it's a big improvement for the near future. And lastly, and most importantly in my pipelines, the templates. I create templates, a template pipeline which is full with parameters. I hate that word in English, sorry. And and with those parameters, I can do a lot of repetitive work. And like I will show you in the next slide, I'm doing my logic mostly in my pipeline. I call it shift left, more to the front. My RM templates were complex in the beginning, and when you look at the Wvd templates from Microsoft itself or the ones that are on GitHub, it's a pain to look into. And I don't like it. So we have an ARM template that deploys a storage account. Nothing more, nothing less, some basic parameters. We have something for the network, something basic. We have the GitHub Wvd deployment template from Microsoft. We've altered them a little bit, and I know with Bicep it will be easier, but it's still RM. And I have built my logic in my pipeline. I will show you later on. And the templates are a most crucial part in there. So for every customer, I build one backbone pipeline, and that pipeline is a multi-phased and multi-stage pipeline. Basically, what it does, it installs an artifact image in front from a default Windows 10 image, which is deployed from the Azure Gallery. From there, I install my own packages that are already in Azure Artifacts from our own pipelines, and I created artifact image. And why I do it in two phases is because some suppliers just won't have silent installations. So we can do a manual intervention in there, and we can do the artifact image once every 3 months, once a half year, once a year, once maybe. And that artifact image is tested, and from that moment on, we go with the automated deployment, and that's only phase 2. So phase 2 deploys an artifact image. It installs the applications that are silent and fully installable, Windows updates included, and after that, it will create a master image. The master image is saved in an image gallery, shared image gallery, and it's fully private. You can replicate it to all zones you want, replicate it multiple times if you want to in the same region whatsoever, and from there you can deploy it to your Wvd host. That's why I call it multi-phase, multi-stage pipeline, and my logic, like I will show you in a second, is pretty much everything I need. Let's go to my pipelines. So this is a Azure YAML pipeline, and this one, the bottom one, is the one we started manually. It took about 2 hours It installs 4 applications and has 2 images and deploys a test and production environment, including the Wvd portal. Sorry, a lot to do. I just click start and that's it. So basically, when I started, I have a lot of parameters. You have variables and you have parameters. And parameters are something you can use at runtime, and it will be evaluated before it got to the DevOps agent. And it's very powerful because you can use objects and you can loop through it and that kind of stuff. So basically, what can we do if we do it manually? I can choose to use a manual intervention in the first phase. So we can use the legacy application in there. Okay, we don't talk about it. We have the Wvd deployment in this case. This is the demo environment from Stefan, and yeah, we've chosen not to use a dev environment. We have chosen to just use the test and the production, and the acceptance and dev are skipped. Pretty basic. I also have the option to create another OU for test and for production. Even the VM size or the number of VMs can be altered right at here at the beginning. And we have the shared image gallery name. We have the host pool where to deploy it. Well, because it's a demo, we just use the hosted one. I prefer the our own one, but that for later, you know how that works. We have a manual run, which means phase 1 and phase 2. And if I click that, we get the result of the bottom one. In phase 1, we will install, for example, 7-zip and Google Chrome. I know we can do it automatically, and we do it right here, but it's just for the example. And in the phase 2, we do Adobe Acrobat, FSLogix. We also have the application image. Those are the steps we need to image. So cleanup, optimize, sysprep, and we do it in 2 parts. And those are packages in our own suite. So it's pretty much the same as applications, but this will be used multiple times. And we can deploy this pipeline internally or externally. We have variables we can use from here. We can change it. Those are all predefined as secure nodes for the demo. You can use a key vault also. We have a lot of stages, all the green marks in here. I won't bother now. And yeah, you can just click run and it works. Well, we get some warnings, so don't start on that. I'm sorry I'm going out of time, by the way, but I'll go on. I don't know if it's that bad and how much time I have to spare for you guys, but I'll try to keep it short. So, oh yeah, I'm trying to show you the result of the pipeline. We start always with a validate. So it's basically a deployment in validation mode. We make sure that the templates we're using are okay. We obviously do it in the release and pull request stages, but I always like to do it here also. I also do a build master version number. As you can see, it's the year and month and an interactive now. Number that goes up every time you run it. I don't know the English word anymore. And from there on, we start a shared image gallery deployment. And we also do the deployment from the gallery. Like I said, everything I told you before. So for example, as you can see here, just a second, we're on this thing, Bevorker. Okay, we're done before 9. I'll make that. And let's start another one. Okay. So as you can see here, I'm installing the Adobe Acrobat, and I have the diagnostics on, so I need to scroll down a lot. And from here, you can see that it's installing. And we get a lot of information back, but we know it's installed because it's okay. After we've installed it, we create an image. Those are just the basic commands we can use. And I think it's better to view to do the YAML view, because I think you guys love that more. Let's start with the backbone. So basically, we have a trigger, we have parameters. This is the pipeline, the backbone. I just showed you the interface from. We have the parameters here. We have the variable file, and we have a lot of stages. I have collapsed a lot of things just to make sure that you can see everything. The entire pipeline and backbone in this case is around almost 600 lines. And let me show you the install application part. This is the image. My bad. The first application. So it was 7-zip at Google Chrome. What I'm doing here is I just start a template. A template that's in here. And I use it, I think, 5-6 times in this deployment alone. So that's why the templates are very powerful in the YAML pipeline, because I can just get one template ready and use it again and again and again. And why is it so powerful? Because I'm giving objects to the template. When I'm looking at the parameter from the pipeline and the applications, you can see that it's an object. And with objects, you can, just like PowerShell, you can loop through it. So a for each loop will run the template every time there's an application here. So when I go to install apps, don't mind all the parameters there. We have an application called object and it's empty. And one of the first things I do in the deployment is check if it's an internal or external pipeline, because we need some logic to download it on a machine. And that's a custom package we have in Azure Devops. It basically you use a command invoke on a machine, which runs in the system. It downloads a PowerShell script from our repository, and from there it uses a hotkey to get all the other applications in there and install and verify all that kind of stuff. This is the magic. For each app in parameters.applications. So for each application I have defined in there, it will check if it needs to skip, if it needs a pre-reboot, and if it needs an after reboot. And it will just use a run invoke with the deploy artifact PowerShell script I just mentioned. That's it. That's the entire template for install applications. And it doesn't matter if I have 50 applications in there or just one. It works just the same, and DevOps fills every step in there. And just to make sure that you understand the logic in here, you can do this with a loop in RM. But the applications and parsing the applications in there is harder than it's in here. And that's why I just use it in my pipeline. I can copy the pipeline in BASIC, just alter the applications I want, and it works again. For willing of the time, I think I'll cut it in here. This one, I think, did I miss something important here for the skipping part?
Well, I don't think so. I think we mentioned all the things we wanted, and like resume or the thing is, with this pipeline, with this mechanism, we are able to deploy a Wvd environment for our customers, install applications, install updates, and do that in a continuous integration, continuous loop. So every month we can install new updates, we will deploy a new test image, the customer will test that new image, we'll verify it, we'll approve it, and automatically the next day there will be a new production environment based on that image that customer has approved, and that's it. We don't have to do anything else. We don't have to do anything more, and that's the power of this mechanism.
Yeah. Just to add something there, because we don't need to do it just once a month. If we want to, we can do it every day or multiple times a day. I don't see the necessary in there, but just in case, you can do it, and that's the powerful thing here. You can use a cron schedule for it. You can use Teams integration with DevOps and just let your first help or first desk, support desk, whatsoever, start the deployment and approve it, or let the customer approve it itself. I think Sander Rosenmuller has a great integration for that. I don't know if he blogged about it already, but yeah, the possibilities are endless. And by combining our software package suite we already have at Firmenity with the YAML pipelines we just showed you, we can just generate a new Wvd environment for a customer. If they have an Azure environment with a subscription and an Azure Active Directory, We have it up and running in, I think, a couple of hours on waiting for everything is installed. But yeah, pretty much that.
Yeah, most of the times we are waiting on the Azure Resource Manager and installing applications.
Yeah, like I said, those 4 applications, including the 2 applications images, it's about 2 hours. And if you just use the automating part and only use phase 2, it's still 1 hour. But yeah, you don't have it's not depending on anything, so you can just start it and wait for it and approve when you want to deploy it. And yeah, that's the power.
And one important thing to mention, we are not using or reusing images, because in most on-premise environments, what you will see is people will make a snapshot of an image, will change something, will try to fix one thing, will break another thing, think it's all done, will reseal the image and deploy it. But it's, well, I have multiple customers where it will take like 40, 50 snapshots based on an image which has one time built like 2-3 years ago. But in this way, it's always a clean, nice image, just the applications, the configurations. If there's something wrong, we can go back in the time. We will have our commitments or our commit in Azure Devops on Git. We know what has changed, which application has been added, which application has been removed, which configuration change has been made. And we can start over and we can just redeploy it back and again and again and again.
Yeah,
I think that's it.
I think that's it. Yeah, we just rushed the demo a little bit, but that's fine. I've shown you most of the things those were important, and yeah, maybe we can do another session later on.
Yeah,
more in depth.
Well, that would be great. I think it's really, really, really nice to see all your passion about this subject, and I think you could keep going for another 2 hours
easily
without boring us. So that's really, really, really nice. Awesome stuff.
You saw some very powerful stuff, and I'm deeply impressed by everything I saw tonight. So thank you.
Oh, you are the Dutch, right? So we have a Dutch user group that does my presentation, I think, in more details from December it was. So you can share it and see it.
It's available online, so
I'll definitely share the link then.
For Dutch friends only, or English people that want to learn Dutch.
Good one.
Cool. So, do you guys have any questions?
Well, yeah, I do have a question. When you compare the running a virtual machine and install Windows on it, are there any limitations compared to Wvd on an image?
Well, the image management part is just a Windows 10 multi-session image, but you can also use the same image management for a Windows Server 2019. It's depending on the RM template you're using in the beginning. And basically we're just using it for Windows 10 multi-session because, I don't know why I should go back to the server variant if I have a Windows 10 multi-session. But you can use it for anything else. And I think you meant that, right?
So now you went to, when you need to choose between a VM or a Wvd, then you would say, don't use the VM for Windows.
Yeah. Correct.
Okay.
Yes.
Yeah. Well, clear. That was the answer to it.
And basically, we can use anything. So each VM size, each OS, it's just a matter of changing a parameter to like Windows 10 multi-session, 19H1. Maybe you want a Windows Server or a Linux. You can even use this mechanism to deploy your application servers. It's just a server OS, it's an application, and it's a image as a result, and you can deploy that image to your environment. So web servers or anything, you can deploy it in the same way, only we combine it with Wvd in this case.
The image management part just generates a image in a shared image gallery. And from there on, I have an extra stage that deploys it to Wvd. But if you leave that stage off and don't use it, you can deploy it manually through the shared image gallery. So
Okay, cool, great.
Yeah, and
great.
the
Yeah.
image management is the hardest part and most underestimated
Yeah.
part in WVD, and
Yeah.
they're not talking about the software
in-
management anywhere.
Incomplete end user computing. It's that's the thing. That's where what the end user will see. That's their working environment. That's their environment if they log on. So and that's most of the times the hardest part, or getting that up to date and getting that thing right.
Cool. Thanks.
Very
Yeah.
cool.
You're welcome.
Very cool. Roland, do you have any questions you want to fire up to the guys, or?
Well, I'm looking at the clock, and it's already 9, but I had a wondering of myself, because the 24th of June, Microsoft will announce this big update to Windows. Can we expect anything on Windows Virtual Desktop there? Because is it something they are going to introduce for more customers? Is it and of course, maybe you don't know, but maybe you can share your general ideas on that.
Well, there is already, because there is it's the image builder on Azure.
No,
And it basically, that's the question, right? If there will be updates on Azure, on Windows to support.
No, it's more the Windows. Microsoft announced that it's going to
26th of June.
Windows in the very near future, and it's going to be huge. It's probably the biggest update ever, like they're saying.
Yeah, for Windows 10 at least.
Yeah, for Windows 10, maybe
Oh.
Windows 11, but is it something more like virtualization in the cloud, and is it something we can expect for customers to see there?
I honestly don't know, and I don't think it is impacting WVD, because if it's a new version on Windows itself, or a big update, or a replacement whatsoever, I think we can use it in WVD also, because we still can use Windows 7 as a legacy OS there.
Of
And
course,
the WVD is the management shell and the backbone to connect to it. And yeah, so I don't think that's related to WVD, but maybe Stefan has.
I'm thinking I know a few things, but I'm not sure if that's
you're allowed to.
talking about it. I'm not even allowed to share it.
Then it's. I think we're out of time then. We won't put you in that position. So thank you guys. Thank you so much.
Thank you very much. Thank you very much, guys.
Thank you for having us.
Yeah, thank you.
Yeah, then this is already the end of this evening. Yeah, really cool sessions again. Thanks for watching all. And also special thanks to our man behind the scenes. Roel, you nailed it. Great job.
And if you have any sessions you would like to present as in the Azure First Day community, we're always looking for speakers, but we're still looking for speakers for the July event as well. So if you have anything you want to share with the Azure First Day community, then give us a shout out and let us know, and then we'll get back to you.
Yeah, that would be really nice. So like Roland already said, we will be back next month. Hopefully see you all again there.
See you there.
Thank you all, and have a great evening, and see you next time.
Yes, bye-bye.
Bye-bye.